Hi, this is Vikas. I'm going to do a concept video on the topic of even functions, which are widely used in maths and in engineering mathematics. They are used in Fourier series and lots of uses of that about even functions. And similar to that, even functions, we even have odd functions. So let's go into the discussion. I'm Vikas from CSC Data Science Department, C section. The subject is about Max LSE. Now, in the first slide itself, we are going to know about even and odd functions. When we go draw a graph, the one which is symmetric about y-axis is an even function. In the above PPT, in the above in the slide, in the first sentence, first diagram itself, we have an example of even function. We have a mirror image symmetric about y-axis. Now what? Now about odd functions, it is symmetric about origin. Like we have an example here, an odd is symmetric about origin. Now even functions have symmetry, y-axis symmetry. Now when we have drawn a graph, we have plotted a graph on a y-axis, x and y-axis, which contains 4 quadrants. So for even function, for every point x comma y on the graph, the point minus x comma 5 is also on the graph. Like, let's take an example, 1 comma 2. The point 1 comma 2 and minus 1 comma 2 is also symmetric about y-axis. That's called even function. Now, odd function has origin symmetric. So for an odd function, for every point x comma y on the graph, the point minus x comma minus 5 is also on the graph. Even function. One way to think about even function and odd function is to consider the graphs. The graph of an even function is symmetric with respect to y-axis, while the graph of an odd function is symmetric with respect to origin. Now, why we have taken a topic of Fourier series? Because in Fourier series also we have an application of even and odd function. That's why I have taken a Fourier series. Now, normally Fourier, we do not need to go as deep into as what is Fourier series and why we require Fourier series and all. I have just introduced 1 or 2 slides and a problem on that and why even function is used in Fourier series and why odd functions are used. That's it. We should not even go to the deep. Like Fourier series can be generally required as like f of x is equals to a naught by 2 plus sigma n is equals to 1 to infinity an cos nx plus sigma n equal to 1 to infinity bn sin x, where a naught is equals to 1 by pi integral minus pi to pi f of x dx. This is first equation. In the formula we require a naught, so the a naught formula is 1 by pi integral pi to minus pi f of x dx. And to find an, it is 1 by pi integral minus pi to pi f of x cos nx dx. Like in the second sigma and first sigma, we want to find an. So the value of an equal to 1 by pi integral minus pi to pi f of x cos nx dx. Pn is equals to 1 by pi integral minus pi to pi f of x sin nx dx. In the secondary integral, we need to find Pn. After applying a and bn and a naught, if we keep in the equation, we'll get a Fourier series. Fourier series makes use of the kind orthogonality relation of sine and cosine functions. A function is even if f of minus x is equals to f of x for every number in x, the domain. So if you plug a minus x into a function and you get this original function back again, it is even. Now let's take an example. See the example there. Let's wait for a second. It's an example there. If we keep x in place of x, if we keep minus x, the value is like, the question is f of x is equals to 5x power 4 minus 2x square plus 1. We need to check is this a function even or an odd function. So if we replace x by minus x, f of minus x is equals to 5 into minus x whole power 4 plus minus 2 into minus x whole square plus 1. That gives 5 into minus x whole power 4 is x, minus 2 into minus x whole square is x square plus 1. So we have got the same function back. What in the question it's given. So that is an even function. Now what is an odd function is like f of x is equals to minus f of x. If we replace minus x with minus x, the answer will be minus of f of x. Then it's an odd function. In the second example, let's check. F of x is equals to 2x cube minus x. We need to check whether the function is even or odd. So if we keep in place of x minus x, f of minus x is equals to 2 into minus x whole cube minus of minus x. So minus x whole cube is minus x cube plus minus into minus x. If we take common, then the equation is minus 2x cube plus x. By this, we have proved that this is not an even function. But whether to check it is an odd function or it's not a odd or even, if you take minus common and the other part of the minus, if we get f of x, it is an odd function. If you take minus common, we'll get minus of 2x cube minus x. So it is same as f of x. So it is an odd function. If f of minus x is equals to minus f of x, it is an odd function. We'll get to know about it in the next one. Now let's talk about even function. There's some like I'll tell some examples: x square, cos x, secant x are even functions which are symmetrical about y-axis, and odd functions are examples which are symmetric about origin, sin x, cos x, and so. Now let's see definition. If function f of x is said to be even if f of minus x equal to f of x. Even function. A function f of x is said to be even if f of minus x is equals to f of x. Like let's take examples: x square, cos x are even functions. Graphically, an even function is symmetrical about y-axis. If we check it here, the graph is also placed a normal f of x function which is symmetrical about y axis. Like if we take, we'll get the same point y if we take x as positive or negative when function is even. Now let's, in the previous before slide we have discussed about Fourier series. There was doubt that why we have brought Fourier series in even functions. So this is the reason. Let's discuss about it in the even now slide, in the present slide. When the function is even, when f of x is an even function, then f of x sin x is an odd function. Like check, f of x is an even function. So f of x minus x is equals to f of x only. But sin x, sin of minus x minus sin x. So the total function is multiplied by minus. So minus f of x is odd function. So that's the line which we are in. Like when f of x is a even function, then f of sin x, f of x into sin x is an odd function. Thus, an is equals to 1 by pi integral minus pi to pi f of x dx equal to 2 by pi integral 0 to pi f of x dx. A not equal to 1 by pi integral 0 to pi f of x dx. Now an is equals to 1 by pi integral minus pi to pi f of x cos nx dx equal to 2 by pi 0 to pi f of x cos nx dx. But here bn will be 0. Why? Because sin x is an odd function. The simple reason, sin x is an odd function, but f of x is an even function. The total even into odd is every time an odd. So the total function is will become odd, but odd into odd function will become an even function. So here bn is equals to 1 by pi integral minus pi to pi f of x sin nx dx equal to 0. Therefore, f of x is equals to a naught by 2 plus sigma n equal to 1 to infinity a n cos nx. Here we have a sum, like to find Fourier series. Like this is not required a lot, just to show the PPT we have given it. Then we'll be substituting this. Now let's discuss about odd functions. A function f of x is said to be even. Sorry, the is spelling odd. F of x, f of minus x is equals to f of minus f of x. Example, sin x, x cubed are odd functions. Graphically, an even function is symmetrical about odd function is symmetrical about origin. Here in the we can even see here, like odd function is symmetrical about origin. Like here also, like another example is x power 5, x power 7, sin x, tan x, and cot x and cosecant x. Lots are there for odd function examples. Like odd function and even function are more important in all subjects when the function is odd. When f of x is an odd function, then f of x cos nx is an odd function, and f of x sin x is an even function. A not equal to 1 by pi integral minus pi to pi f of x dx is equals to 0. An is equals to 1 by pi integral minus pi to pi f of x cos nx dx is equals to 0. Pn equal to 1 to pi integral minus pi to pi f of x sin nx dx equal to 2 by pi integral 0 to pi f of x sin nx dx. Therefore, f of x is equals to integral n to 1, n equal to 1 to infinity bn sin nx. Here also we have an example of cos nx as Fourier series cos function example. Note, there's a note like we have properties. The product of two even functions or odd functions is an even, whereas the product of even function and odd function is a odd function. Let's come again. The product of two even functions or two odd functions is an even function, whereas the product of an even function and an odd function is an odd function. Like the product of two even functions or two odd functions is even. Like if you take example, two even functions, x square into x square into x power 4. It's x power 6. So x power 6 is an even function. Like if you take two odd functions, x and my x cube, x into x cube, it is x power 4, and this is also an even function. This is a line. The given function not necessary even or odd, or it may be or may neither. Even function can be uniquely decomposed into the sum of an even function and an odd function. That is f of x is equals to f of x plus f of minus x by 2 plus f of x minus of f of minus x by 2. That is equal to f1 of x plus f2 of x, where f1 of x is even function and f2 of x is odd function. And at the last, uses of even or odd functions. Even and odd functions the various uses in mathematics and physics. Here are some examples. In Fourier analysis, even and odd functions are used to simplify the process of finding the Fourier series of a function. The Fourier series of an even function only contains cosine sums, while the Fourier series of an odd function only contains sine terms. Even and odd functions are used in integration to simplify certain integrals. For example, the integral of an odd function over a symmetric interval is always 0. In physics, even and odd functions are used to describe certain physical phenomena. For example, the electric field of an uniform charge sphere is even function. Even and odd functions are used to simplify the solution of differential equation. For example, it is if a differential equation has an even solution, then it is sufficient to find the solution for n positive x. That's all for today, guys. This is about even and odd functions. We have discussed a lot about even. Like even functions are symmetrical about y-axis and odd functions are symmetrical about origin. And even function is f of minus x is equals to f of x. And f of odd function is f of minus x equals to my f of minus x. And we have seen the uses in Fourier series as well as differential equations. And integration is also uses. Thank you one and all. Thank you for this session. Thank you.